Hi, I'm Sri Charan. This is Digital Signal Processing Lab 3. Today we are going to compute pulse rate from a PPG signal and pitch period of a speech signal using autocorrelation function in real-time Arduino prototype platform. For PPG signal, assume sampling rate of 100 Hz and resolution of 10 bit and frame duration of 5 seconds to compute the pulse rate from a PPG signal. For speech signal, assume sampling rate of 8000 Hz and resolution of 10 bit and frame duration of 30 milliseconds to compute the pitch period from a speech signal. Autocorrelation function. Autocorrelation of discrete time signal is defined as R of m equals to 1 by R of 0 into sigma n equals to 0 to n minus m minus 1 x of n into x of n plus m, where m equals to 0 to n minus 1. ACF reveals how the correlation between any two values of a signal changes as their separation changes. This is the output of a code. I'll show you the code now. G G is the signal, input signal. It has 2000 samples, and now we are dividing the signal into blocks of 500 samples, and then we are calculating the moving average, and then average of a signal. We are calculating the average of a signal. Average, that means we are calculating the mean of a signal. In this for loop, we will get a mean as output. Sum1 is the mean, and we are removing mean and calculating ACF at the same time in this for loop. In this for loop, we can see that y of j is the moving average signal of a one block, and we are removing mean. Sum1 is the mean, and then we are calculating ACF. Now W of I is the ACF of a signal, and then P is equals to W of 0. It means P is the power of signal. As we know, R of 0 is the power of signal in autocorrelation. We'll divide the autocorrelation with power of a signal to get normalized autocorrelation values, and then we'll find the location of zero crossings. The location of zero crossing, this is the logic to find the zero crossings of a signal, and then we'll find the maximums. In this loop, we are going to find the maximum value after first zero crossing, and then we'll add the uh, time duration. I'll show you the value here, and we'll find the first zero crossing of maximum after first zero crossing. That means this is the maximum after first zero crossing. This is the first zero crossing. This is the first zero crossing, and this is the maximum after first zero crossing. And t means from this point to this point, this maximum x value, and the total length is the bit. Now we have to add the t plus k. That means first zero crossing value plus first maximum after first zero crossing index, and we'll get the t plus k value, that is time, and we'll find the h equals to 60 into fs by t plus k is the pulse period, and this is the output. This is the output. In our autocorrelation function, the distance between two maximums is approximately equal. That is, from this maximum to this maximum is equal, and this maximum to this maximum is equal, but it is a decreasing function. It is linearly decreasing function. That means we'll get a straight line if you add this points, maximum points, and it reveals the frequency of frequency characteristics of non-deterministic signals. It is helpful in to find the frequency characteristics of non-deterministic signals. Properties of ACF. Articulation function is even function, that is R of minus m is equals to R of m, where m is the time lag or time delay. R of 0 gives energy of the signal. ACF of periodic signal x of n is also periodic with period equal fundamental period of x of n. It is monotonically decreasing function with respect to peaks. As I said, ACF has maximum value at m equals to 0, which implies signal matches perfectly with itself at 0 shift. And for the PPE signal, this is the PPE signal, and this is the autocorrelation of PPE signal. A and P, these are the two peaks of PPE signal, and these are the two peaks of autocorrelation function. As I said, the property solar, it follows every property as I said, and it is monotonically decreasing. And okay, now we have to do the same procedure. That is, we found out the pitch period for PPE signal in the code. That is B60 into Fs by T plus K. The same code is applied to find the pitch period of speech signal. To record the speech signal in MATLAB, we have to use these commands. My voice is equals to, it is a variable, we can use any other variable. Audio recorder of 8000 sample frequency, and these are the bitrate and record blocking of 2 seconds, my voice 2 seconds, and these are the commands you should use to record the audio from our speech from MATLAB. And we'll get the audio data in B. We have to use the audio samples in the same code to get the output of pitch period. And to compute pitch period, we have to follow this procedure. Find a maximum amplitude of ACF and its location from first zero crossing point as by following procedures as given below. Compute the location of first zero crossing point of the ACF sequence. First location of compute location of first zero crossing point from the ACF sequence. So I will show you the code. Here in this for loop we are calculating the first zero crossing. It means if it if it gets the first zero crossing, it will come out of this loop, this for loop, and the first free zero crossing value index is stored in this K. And then construct a window having the ACF values from a first zero crossing point to last values of ACF vector. That means from this is the first zero crossing value, and from this we have to remove these samples from starting to first zero crossing. We have to remove the samples, and the signal now we have to process is from this first zero crossing to the end, and then compute the maximum value of a window and obtain its maximum location L max, that is in maximum after first zero crossing. That is, this is the first zero crossing and this is the first maximum after first zero crossing, and we have to find the index of this first zero crossing. Hmm? That is, since we took the window from this point to this point, we'll get the index from with reference to first zero crossing. That is, first zero crossing is taken as 0. So we'll get the index location as Lmax and compute the maximum amplitude location as given below. Maximum amplitude location. So we got the location of first maximum here. Suppose this is the maximum location uh, first after zero crossing is 5 index. That 5 is referred from first zero crossing but not from here starting of the signal. So I have to add the index of first zero crossing to that 5 value. So we'll get have to find the uh, amplitude location by this equation. Lmax 1, that is first zero crossing equation index is equals to index of first zero crossing plus index of second window, what we have found in the second window, and compute the period of signal as given below. We'll get the position of first maxima, and then we have to divide the maxima by sampling frequency, and then we have to display the PPG signal, speech signal frequency. And these are the samples. We took 6,000 samples for speech signal, and this code is same. We didn't change anything. We have to divide the signal into 500 blocks, then we will get the pitch period. This is the pitch period. Thank you.